Hi, welcome to another Unity Mobile from Scratch tutorial. In this tutorial, we're continuing in our series of moving the 3D object around using the mouse or a touch on the screen. Now, we're up to looking at the perspective camera. In the previous tutorial, we looked at the orthographic camera where everything is projected in parallel. When you change to a perspective camera, things become a little bit more complicated. Mathematics wise, but once you get your head around that, the code isn't longer. Maybe it's even shorter than the other way around. And when you solve the problem using the perspective camera to move these objects around, then you also solve the problem of having the camera looking at the world from any angle. Okay, so first of all, let's just revisit the mathematics in this. Okay, so here is the little diagram showing our viewing volume of a perspective camera, okay, which is basically a pyramid shape. Now, all the rays that come out from the camera aren't parallel, because if they are, you only get a single line projected straight out no matter where you move on the screen. And we talked about this a couple of videos ago when we first introduced the issue. Now, as you can see, I've got some spheres set up in this environment. Now, we want to click on a sphere and we want it to move in its own X and Y position, but that X and Y position has to be parallel to the camera's near plane, or in fact the far plane, because these two planes are actually parallel anyway. So it's like drawing a big plane in here and making sure that the ball, as we move it around, stays on that plane. So it's not always the same distance from the center of the camera, but it always stays in a plane that's parallel. Because if we look at lines that are projected from the mouse position on this little screen here of the near plane, they radiate out. And so therefore they're not all hitting the same plane because of the fact that they're kind of like umbrella spokes in a way. Okay, but a plane here is not the same distance back down to here from all of the points on that particular plane because of the nature of this sort of pyramid structure. Once you get your head around that, what we're doing is we want to click on the screen. We're going to use our ray code that we've already written to grab hold of a sphere and then move it around, but keep it on its plane that it already exists on. So it's always going to be moving in a plane that's parallel to the camera, which means that it doesn't matter which way that camera is facing. Because of the way we're going to calculate the plane, then angles will not matter. All right, so let's have a look at the code now. So this is the Touch Manager code that's been updated to include planes. Now, right at the top, we've still got our grabbing hold of an object, and we still have our mouse offset because we can grab the sphere at any position on the sphere, not just right on its center. Okay, so we need that, although we will calculate it slightly differently than we did before. And we've got this object called an plane. So a plane is basically it's a great big polygon. Okay, so it's like a quad in space somewhere. It's perfectly flat, but it does have a location, and it also has a normal. And the normal tells us which way that plane is facing. In the diagram, I've now added in a particular plane. So if we're talking about this sphere here that we want to move around, we want to move it around in this plane. And the plane will be constructed using the very center of that sphere, or the position of that sphere, and the normal, which will be the opposite way of the camera's forward axis. So the camera is facing in this direction outwards, but the plane has to face towards the camera, and we can just flip around the forward vector of the camera, which will make the normal of the plane. So here's the normal facing straight back to the camera. Now, by defining this plane using the sphere's position and this normal, we're then able to keep the sphere on that plane. Right, let's go back and have a look at the code. So there's our plane. Now we've got our generate mouse ray code as we had before, so we'll just leave that. All of the changes are really inside of the update function. Now we're going to create the plane when we first pick up the object. So this is on our touch or on our click. We pick up the object if we've actually clicked or touched over the top of something. So this is us grabbing hold of it again like we did before. But this time we also generate the plane. So this is the object's plane created from the camera's forward vector, but flipping it around. So by multiplying it by -1, we can create a vector which will become the normal for our plane. And the plane is in the exact same position, or it passes through the position of the object that we've clicked on, which is very important. So that's creating that plane. One-liner, really simple. Now, after that, we then calculate the mouse offset. As we had to do before with the orthographic camera, we also need to do the offset with the perspective. Now, this is a little bit different because we can't rely on the X and Y position for our offset. So instead, what I'm doing is calculating where the mouse input ray is actually intersecting with the plane that we just created, which is this line here. So we do a plane raycast, giving it the plane, giving it the ray, and determining where we actually hit that plane. And using that plane hit point, the difference between that and the actual position of the sphere will give us our offset. And then we use that the same way we did before. Now, down in the code where we're actually dragging around the object that we've got hold of, we're doing a raycast using a screen point to ray function instead of screen point to world. And this turns our mouse position into a ray, which goes out into the world, hitting that plane. So we're doing another raycast. So this code up here for calculating the offset and this down here is pretty much doing the same thing. It's just determining where your mouse is hitting that plane that we've created. And then we use the position where we're hitting that plane to update the location of the object that we've got hold of, plus, don't forget the offset value here. And then when we release the mouse, if we've got hold of something, then we let it go by setting it back to null. So save that, go back and have a little play with this. So if we press play, we'll be able to move these around quite nicely. Now this is all happening in the perspective camera, as you can see here. And we can move that camera and actually rotate it around. Just to test that our theory still works fine. And I press play again and we can move things around. And they'll stay in their plane. Okay, so that's the perspective camera, which, by the way, because of the theory we're using with the plane, will also work for orthographic. So if we go switch to orthographic and press play, it also still works for there. So this second lot of code, although it was developed for perspective, now covers all possible situations for your camera. So if you're wanting to move your camera around, or even if you're not, you can use this code and just be assured that it will work in all cases for all different camera projections.